Eigenvalues, eigenvectors, eigenthings, eigenpen, right? Eigenman, like the weirdest math superhero ever. Let's play with all of these eigenthings with our eigenpen on our eigenboard. We have a 3 by 3 matrix. We are told an eigenvector, let's find the eigenvalue. We're given a different eigenvalue, find the eigenvector, or an eigenvector that goes with it. And then we're going to do something with these two eigenvectors and play around with it a little bit. So, this is an eigenvector. What does it mean? Well, it means, let's go up here. It means that 1, 3, 3, minus 1, minus 3, minus 5, 1, 1, 3 times 1, 1, 2 is equal to lambda times 1, 1, 2. Well, let's do this. 1 minus 1, 0 plus 2 is 2. Now, this is already telling me pretty much that lambda is going to be 2, right? But let's just make sure. 3 minus 3 is 0, plus 2 is 2. 3 minus 5 is minus 2, plus 6 is 4, and that is 2 times 1, 1, 2. So my eigenvector here, eigenvalue is 2. Other way around. 1, 3, 3, minus 1, minus 3, minus 5, 1, 1, 3, times some vector x, y, z is minus 2 times x, y, z. Now what does that tell me? Well, x minus y plus z is equal to minus 2x, so we're going to need that. We're going to need 3x minus 3y plus z is minus 2y. And we're going to need 3x minus 5y plus 3z is minus 2z. Well, okay then, be that way. Let's tidy this up a little bit. This tells me that 3x minus y plus z is 0. It tells me that 3x minus 5y plus z is 0. And it tells me that 3x minus 5y plus 5z is 0. Right. That's a minus y there. Better? Better. All right, so I've only really got 2 of these. So, yeah. If I just subtract these 2, I'll go minus y minus minus 5y to get 4y minus 4z is 0. That tells me y is z. If we put y as z, plug it back into there, we will see that x is 0. So a good eigenvector for this would be, all right, I'm going to put the answers in here because I'm going to need the board. Red pen, I feel like the red pen is good. That was lambda is 2, and a good vector for this one will be x is 0, and then y is equal to z. Let's go for that. Awesome. Awesome, awesome, awesome. Right, let's get some board space. Bigger boards just mean bigger questions. Right, now, a to the 7 times w. Well, let's just see what that means in general, right? A to the 7w is a to the 7u plus a to the 7v, what my 2 vectors are. Now, every time I multiply u by a, I pick up a factor of 2. So what this is that is just 2 to the 7 times u, and this is minus 2 to the 7 times v. Now what this means is it's actually 2 to the 7 times u minus v. Now depending on your v, of course, this might be different. This is very much the natural one to pick. But overall, we should end up with this, 2 to the 7u minus v. So that is 2 to the 7 times 1 minus 0 1 minus 1, 2 minus 1. So what's that? That is 128, 0. 128. Nice. Nice, nice, nice. Cool. That was a little bit quicker than I thought. Very nicely done. Well done, everyone. Well done. All right. If you want to spend more time hanging out and doing a bit of vector revision ahead of your further maths exams, check out the link in the description below. We are running cram sessions. So the night before your exam, you get a 5-hour live stream with me, and we'll be going through exam-style questions, making sure we've picked up on all the little intricacies going into your exam the next day, and making sure that you are feeling confident and ready going into the monster that is a further maths A-level exam. Also, if you sign up for the further maths cram sessions, we'll also throw in maths A-level for free. So go check out the link in the description below. I keep pointing below in case you don't realize that's where below is. I don't know what I'm doing. Please, hopefully I'll see you there. Otherwise, I'll see you next video.